So this is the tailstock of the lathe I picked up last June. It's a Jet 1660. And this, getting it onto the floor without the hoist was a bit of a beast, because it's pretty good size. It's, with the quill out, it's 23 inches long. So, I mean, the casting is 14 inches. And, I don't know, probably weighs about 150 pounds. Anyway, what we're going to do today, so it's got a problem. This is the clamp for the quill. Anyway, this is a split nut clamp. So this piece goes in here. It's threaded inside. It looks like about 12 millimeter. This is a slide, and they go down in a bore in here and pinch the quill. So as part of that, there's this piece that goes through here, threads into that, and the way it works is that there's a pinned nut goes on here and rotates this, and there is a slot in here. It's not even 90 degrees, I would say. Maybe it is. Anyway, and there's a pin, you can't see it, it's on the other side of this, that limits the amount of travel this has. Well, when this is cranked full up against the slot, or against the pin, the stop, this doesn't quite lock. The quill can still move, not by much. It only needs to go a little further. Or we need to put a shim between these two. Well, the shim would be a lot of trial and error. I mean, I could make it so it's about one thread pitch, say a millimeter thick. But I think the first I'm going to do is we're just going to make this slot bigger, this cutout. So I think that'll be the easiest thing to do, and it'll be relatively interesting. I think we'll put this in the rotary table, find a center, and then about a 1/4 inch end mill, and we'll just take some off so that it can rotate a little further. It's actually going to be on this side, I believe. We'll verify I get that right. So this sits in there like this. It turns this way when we need to lock it. So we're going to take some metal off, probably about that much, approximately. Doesn't really matter. I mean, it matters, but it's not a really precise thing. Anyway, let me get the camera moved, and we'll set up and get this done. Okay, we're over at the mill, and I took the vise off and mounted up the 8-inch, I think it's a phase 2 rotary table. I picked up, I don't know, last year, I think. I don't know if I've shown it or not. Anyway, it's pretty good. It works good. I've got a really big, I don't even know what brand it is. It's a good one. A big 12-inch one, but the thing is huge, and I don't have a chuck for it. And, for this is perfect. Anyway, so basically we're just going to put this in here, and then we'll find center. Just use an edge finder for that and a DRO, easy. I've got a 1/4 inch high-speed end mill. It's a short one, but that's fine because we don't need to go, but 1/4 inch deep or so. This slot is almost exactly a 1/4 inch deep. Not quite. It's actually slightly shy, but it's perfect for what we need. This will do exactly right. So we'll put that in there, touch off, and then just bring this over and take some out. Probably do this in a couple of passes. I don't want to go too deep. I'm not sure. This doesn't look very hard. I mean, it scratches with the end mill pretty easy. But that's going to be about it. It shouldn't be too bad. So we'll just put this in here and get going. You can't quite go all the way to the bottom, which is fine. Just go there. That's snugged up. And we'll put, probably have to We'll get the phase converter turned on. Compared to my older videos, the phase converter, I don't know if you can tell the difference, it's quite a bit quieter than the old one, which was a 7.5 horsepower Delco motor from the 1950s. This is a 15 horsepower American rotary I had to buy to feed this lathe, and it's quite a bit quieter, and the mill actually runs smoother. So we'll just kind of drop that in there. Nothing fancy here. We'll just use the let's see, what speed are we on here? We're gonna run about 1725 right now. Anyway, we'll just use this to find center. 0 RY. And 1/2 on Y. And I had somebody ask me once, you know, if I was worried about it being centered in the X when I did the Y, and it really doesn't matter because it's round. So even if it's off, it's still going to touch on a tangent on both sides of the hole, or circle in this case. We'll zero that. And 1/2. Okay, so we're centered, so we're good there. This really shouldn't take very long. Should be a quick video. And we'll just put the end mill in there. And I probably could have run this at where we were at. This is for 1/4 inch and mild steel on my chart, about 1600, but you know, I'm in no hurry, and I want the cutters to last a little bit. So anyway, we'll bring this over. Yeah, that'll work. And I'm just gonna use the quill DRO. Here, we'll turn it on. We'll just touch that and set 0. Oh, I think the battery just went out in it. Yeah, anyway, that's fine. So I've touched off and locked the quill right there. And so we'll just move this out a little bit and make sure that we're good. That's 1300. That'll actually be good. So it's touching a little bit, but that's fine. But what I want to do is we'll just bring this around. And we want to, let me zoom in a little bit so you can see, I think. So what I want to do is we want to bring the cutter in so that it touches this inner piece. We'll bring it in the Y-axis, and then we'll just start coming over on it in the with the rotary table. Is that touching? I think it is. So I'm just gonna leave that locked, and I'm gonna drop the knee so that we don't take this full depth of cut at once. Touch off right here. Is this thing locked? It feels locked. Hang on. Yeah. And he was partially locked. Anyway, we'll go down, and we're just touching there. I will zero the Z-axis, or Z, depending on what part of the world you live in. And we'll go down. We're just going to go 50 thousandths. And I think I'll have to figure out where to stop. So right now the table's reading about 330 degrees on here. We'll go over to the 300 mark and we'll put a 30 degrees more travel on this. Well, this is cutting extremely easy, so it's soft. So we're going to call that our 30 degrees. You know, I'm going to go a little more than that. Let's go 45. Which will be 285 on the dial. And then I'll set a 0 here on the rotary table. There we go. We'll call that good. Come over here. We'll take another 50 thousandths. You'd probably go a lot more than that, but this seems to be very soft and the cutter's nice and sharp. And there's our 0. If that shows up at all. Let's see. Okay. We'll go down. We'll just go another 50. I'm in no hurry. I would guess we've got about 50 or 60 thousandths to go. So there's our 50. I think I'm just going to go until we touch bottom on this. Right there. So that was exactly, it was pretty close to that. This will be our final pass. And there. It's actually just taking a tiny bit off of the existing surface, which I'm just going to let it do. That way it'll make it a nice blend all the way. And this is to the original corner. We'll call it that, and we'll just go in a little bit that way. We'll call that done. Okay, so here's our modified part. We now have 45 degrees more travel on the handle. You know, I think I'm gonna bring that out just a little bit. Like I did on this side. Let's turn this back over. Go back. Well, because I forgot to set 0 after I found that edge, we ended up taking off a little extra, which is fine. It won't hurt anything, and we'll have a full smooth pass all the way along, make it look good. Not that you can even see it when it's on the lathe, but it'll be good. Okay, another 10 degrees. Alright, there's our 0. Now we will go in on the Y. Alright. Now we'll call that good, because that comes out tangent now much better. So we'll deburr this and then see about getting it back together. See. Yeah, you know what? Before I do that, whoops. One of those, just, you know, take the cutter out before you reach around, because, you know, running your hand across the back of that is not fun. And I have cut myself pretty badly one time on that, so don't do that again. Anyway, let's see how good that'll show up on camera. Let's see if that'll show up. So there's our another view of our part. So now we can't really tell where we started in our original's got a little I don't know, I want to say burr. It's got a little wear on the corner where it was hitting the original pin. So here's our new side. Here's our original. Anyway, it looks pretty good. Take a small file, deburr this, and I'll see you back over at the lathe. Okay, we're back over here with the tailstock. We'll try to get this assembled and have it show up on camera. Hopefully it will all show up. Let me turn this a little bit, maybe that'll be better. Anyway, so we've got our clamp screw. I did it off camera because it's not a big deal. I did put this in the other lathe and just polish this a little bit with some 400 grit emery paper, because I had to do a lot of prying to get this in and out, and I didn't really want to have to hammer it back in. So now it is just an absolutely, there's a little bit of drag. It's just a perfect fit in there. And that's actually held in with a taper pin. So once this pin is driven in there, it's not going to move. And then, sorry, I keep leaning in front of the camera, but I left everything over there. So this is the stop pin that just sits in the side of the casting right here. It's actually loose in there, but it's captive because of the cutout in there, so it can't really go anywhere, so that's fine. Ideally, it would be a little bit snugger, but I'm not going to worry about it because it just doesn't matter. So anyway, we've got our split clamp. I've already wiped the bore out. It's nice and clean in there. And then wipe down the spindle. So we'll put this in. A little bit of oil on here, of course. It should fit pretty good in here. It was snug coming out. Well, if it'll get it lined up. Let's see here. There we go. That's good, because I had to tap it a little to get it out too. So what I've learned earlier, when taking this apart, is we'll put a little oil on our threads here, is that I can't just you know, screw this on any random distance. It's got to be in the right place to lock up, because what I originally tried was taking this out, giving this one turn, and then it was too much. I couldn't get it together. It wouldn't seat. So, well, actually it would seat, but it would seat before it got to the slot where that stop pin is. Whoops, that's upside down. So that's good. That went went in nicely. So now I can thread this in, and this is the big reason I wanted to make this easier to slide on, is because before I had to put a block on there and just hammer it into place, and that's not good for anything. So we'll push this in, we'll get it lined up with the pin. So this is the big side of the pin. And this is, you can't see this, but I'm just enough to get the pin in to assure the distance. And obviously we've got to go in quite a bit more. So that's going to be the position. And the problem is that I didn't put the stop pin in there, which is fine. So we're going to count the turns to unthread this. So there's 1. I'm using the hole in the side of this. It's on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. So about 8. We'll put our pin in there. Actually, yeah, that won't work. I can't just screw it straight in because it's going to hit the stop. I guess it doesn't really matter how many I counted. Yeah, I guess it will. No, it won't. So ignore that. What I'll have to do is pull this back off. Give this about another turn. And check our alignment here. That actually looks pretty good, I think. Let's line our, see if our pen will line up. Now the question is, well, yeah, look at that. So now it starts tightening, and I've still got probably 20 to 30 degrees of tension we can still put on here. So I'm gonna actually call that good for now. We'll give this pen a little more love to get it seated all the way. There we go. So that's locked in place. And then we've got a just a cap that goes into this just to keep the mess, the dirt out. And we just took off some of our lovely cheap paint. I think that's seated all the way. So we're good there. You know, and I'm going to clean this up some before I get it on the lathe, so you won't see that tonight. And I've got to get the hoist out to do it. Getting this down here was a little worrisome on my back. I am not going to try to put it back on there by myself without getting the hoist out. So it's heavy, as you can probably tell. See, hopefully this will show up. Okay. So now we need to just put this lever back in here. It too has a taper pin, which is easy to tell because it won't hardly go and start on that side, so it goes this way. This one actually came out relatively easy, so I did not try to massage it. Just trying to keep the pin lined up when I tap it in. It actually looks pretty good. Yep, got it pretty close where the pin started. And that's one of the reasons I had to take this off of the lathe, is the with the this original pin, even all the way back, I couldn't really get a punch on this very easy, at least tapping from the bed up. So I take this whole thing off so I could get this pin driven out. So anyway, now it will go over that far for its lockup, and yeah, it locks up good now. So I think even hitting it hard, we still have probably 10 or 15 degrees worth of travel left. This is definitely not going to extend too far forward. We'll get the handle and thread that on there with a little drop of Loctite, keep it from coming loose. And I think this will be a success, definitely a success. And so this was one of the few things left to do to get this lathe really ready for use. I apologize. I actually have shot some video of some of the other repairs. I lost a lot of it. I found out I had a bad connector on one of the camera batteries, and it would shut down mid-recording, and the entire thing was lost. It was not recoverable, which I'm sorry about that. But I have put a new, and I'll do a summary video on this one of these soon days, I hope. But I have put a new motor in the lathe. I had to redo the braking system because the motor required new mounting, and I'll go over all that. Like I said, I shot video on it, and a lot of it's just gone, unfortunately. Let's see what else. I do have a DRO for it. I don't know if I'll do a video on mounting that or not. I mean, there's a lot of them out there. This one is a little different because it does have a taper attachment, and it's just a lot bigger machine than you usually see in the videos for mounting stuff like this, because it's a 60-inch bed. It's pretty massive. As you can see by the tailstock, it's pretty hefty. It's not like a Monarch or something, but it's a pretty substantial machine. It weighs, I think, about 5,500 pounds. So it's about triple the horsepower and triple the mass of my Precision Matthews 1440, which is still a very good machine. I have no real complaints about it, other than, sometimes it lacks rigidity, and there's just certain things I can't do on it. This one's got rigidity in spades. It definitely has it. Oh, put a little. Forgot about this one's a little loose too. So we'll get a little Loctite for this knob, and I'll clean it off. And I'm not going to show that on camera, but. Anyway, thanks for watching. I will endeavor to get a little more of these out soon. I've actually had a few really nice comments lately, which really helps. It's been a kind of a rough last year, but life goes on. Things are getting better. So anyway, I really appreciate y'all watching, and I will hopefully talk to you soon. Bye.